Arc fault circuit interrupter breakers, known as AFCI breakers, sometimes trip when used with electronic fan controllers. This issue stems from compatibility problems between the two devices. This problem is not unique to any particular manufacturer of electronic fan controllers, it affects them all. The National Electrical Code, referred to as the NEC, now mandates AFCI breakers for all bedroom circuits. This includes circuits that serve fans and fan controls. Electronic fan controllers generate electrical noise, and this electrical noise can inadvertently trigger AFCI breakers, causing them to trip. AFCI breaker manufacturers had until 2007 to develop breakers that were not tripped by fan controls. Unfortunately, that deadline has passed, and there is no guarantee of a foolproof solution at this time. Let's look at some potential solutions. Firstly, consider using a simple toggle switch instead of an electronic fan controller. Secondly, experiment with different AFCI breakers from various manufacturers. A breaker from one manufacturer might be less susceptible to the electrical noise generated by the fan controller than a breaker from another manufacturer. It's also worth trying different breakers from the same manufacturer, as there can be variations in sensitivity. Contact the AFCI breaker manufacturer directly for advice. They may have specific recommendations based on the type of fan controller being used and their latest breaker designs. It is crucial to consult with a licensed electrician for any electrical work. This includes the installation or troubleshooting of AFCI breakers and electronic fan controllers. They can ensure that all work is done safely and in accordance with local electrical codes. Understanding the interaction between electronic fan controllers and AFCI breakers involves several key aspects. These include the nature of AFCI breakers, the electrical characteristics of fan controllers, and the relevant codes and standards. Let's delve into each of these areas. AFCI breakers are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors, creating a spark or arc. These arcs can generate high temperatures and ignite nearby materials. There are two main types of arc faults: series arc faults and parallel arc faults. Series arc faults occur when there is a break in a single wire, interrupting the flow of current. Parallel arc faults occur when there is a short circuit between two wires. AFCI breakers use sophisticated electronics to distinguish between normal arcs, which occur during the operation of electrical devices, and dangerous arc faults. They monitor the current and voltage waveforms for specific patterns that indicate an arc fault. When an arc fault is detected, the AFCI breaker trips, cutting off the power to the circuit and preventing a fire. Electronic fan controllers use solid-state components to regulate the speed of the fan motor. These components, such as triacs or silicon-controlled rectifiers, rapidly switch the current on and off to control the amount of power delivered to the motor. This switching action generates electrical noise, which is characterized by high-frequency voltage and current fluctuations. This electrical noise can interfere with the operation of other electronic devices, including AFCI breakers. The electrical noise produced by fan controllers can mimic the characteristics of an arc fault, causing the AFCI breaker to trip unnecessarily. The sensitivity of AFCI breakers to electrical noise varies depending on the manufacturer, model, and design. Some AFCI breakers are more prone to nuisance tripping than others. The National Electrical Code, referred to as the NEC, is a set of standards for electrical installations in the United States. The NEC is updated every 3 years and is adopted by most states and local jurisdictions. The NEC contains requirements for the installation of AFCI breakers in residential circuits. The NEC now requires AFCI protection for all branch circuits that supply 125 volt, 13 amp, and 20 amp outlets installed in dwelling units. This requirement includes circuits that serve bedrooms, living rooms, dining rooms, and other areas. The NEC also requires AFCI protection for branch circuits that supply lighting outlets in bedrooms. The purpose of these requirements is to reduce the risk of electrical fires caused by arc faults. The NEC recognizes that electronic fan controllers can cause AFCI breakers to trip. The NEC provides some guidance on how to address this issue. The NEC allows the use of an arc fault circuit interrupter to protect a branch circuit that supplies a ceiling fan, but it also requires that the arc fault circuit interrupter be specifically listed for use with ceiling fans. If an arc fault circuit interrupter that is listed for use with ceiling fans is not available, the NEC allows the use of a standard arc fault circuit interrupter, but it requires that the circuit be tested to verify that the arc fault circuit interrupter does not trip when the ceiling fan is operated. In addition to the NEC requirements, there are also Underwriters Laboratories, referred to as UL, standards for AFCI breakers. UL Standard 1699 covers arc fault circuit interrupters. This standard specifies the performance requirements for AFCI breakers, including their ability to detect arc faults and their immunity to nuisance stripping. When selecting an AFCI breaker for use with an electronic fan controller, it is important to choose a breaker that meets the UL 1699 standard. It is also important to consider the breaker's sensitivity to electrical noise. Some AFCI breakers are designed to be more resistant to nuisance stripping than others. To minimize the risk of AFCI breaker tripping with electronic fan controllers, consider the following best practices. Firstly, choose an AFCI breaker that is specifically listed for use with ceiling fans. Secondly, use a high-quality electronic fan controller that is designed to minimize electrical noise. Thirdly, ensure that all electrical connections are tight and secure. Fourthly, avoid running the fan at high speed, as this can generate more electrical noise. Fifthly, consider using a line filter to reduce the amount of electrical noise on the circuit. Sixthly, consult with a licensed electrician for assistance with troubleshooting and resolving AFCI breaker tripping problems. In addition to the above information, it is important to be aware of the following safety precautions. Always turn off the power to the circuit before working on any electrical components. Use properly insulated tools when working with electricity. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, consult with a licensed electrician. By understanding the interaction between electronic fan controllers and AFCI breakers, and by following the above best practices and safety precautions, you can minimize the risk of AFCI breaker tripping and ensure the safe operation of your electrical system. Let us now elaborate on the potential solutions and provide a more in-depth analysis of why they might work. Firstly, using a toggle switch instead of an electronic fan controller completely eliminates the source of electrical noise that triggers the AFCI breaker. A toggle switch simply turns the fan on or off without any electronic speed control. This is the most reliable solution to prevent nuisance tripping. However, it sacrifices the convenience of variable fan speeds. Secondly, experimenting with different AFCI breakers from different manufacturers is based on the fact that AFCI breakers vary in their sensitivity to electrical noise. Some breakers are designed with more sophisticated filtering and signal processing to distinguish between genuine arc faults and harmless electrical noise. Trying a breaker from a different manufacturer or even a different model from the same manufacturer might yield a breaker that is less prone to tripping with a specific fan controller being used. It is a trial and error approach. Thirdly, contacting the AFCI breaker manufacturer for advice can provide valuable insights and potential solutions. The manufacturer's engineers have in-depth knowledge of their breaker's design and performance characteristics. They may be aware of compatibility issues with certain fan controllers and may have specific recommendations for resolving the problem. They might suggest using a particular model of breaker, installing a line filter, or adjusting the breaker's settings if possible. Now let us delve into the technical reasons why electronic fan controllers generate electrical noise and how this noise can interfere with AFCI breakers. Electronic fan controllers typically use a device called a trike to control the speed of the fan motor. A trike is a solid-state switch that can rapidly turn the current of the motor on and off. By varying the amount of time the trike is on versus off, the controller can adjust the average voltage applied to the motor and thus control its speed. The rapid switching of the trike creates sharp changes in the current waveform, which generates high-frequency electrical noise. This noise can propagate through the electrical wiring and interfere with other devices on the circuit, including AFCI breakers. AFCI breakers are designed to detect specific patterns in the current and voltage waveforms that indicate an arc fault. These patterns include sudden changes in current, high-frequency components, and distorted waveforms. The electrical noise generated by fan controllers can mimic these patterns, causing the AFCI breaker to mistakenly identify the noise as an arc fault and trip. The sensitivity of an AFCI breaker to electrical noise depends on its design and the algorithms it uses to detect arc faults. Some breakers are more susceptible to nuisance tripping than others, especially when used with devices that generate significant electrical noise. In addition to the track switching, other factors can contribute to the electrical noise generated by fan controllers. These factors include the design of the motor, the quality of the components used in the controller, and the presence of any filtering or suppression circuitry. High-quality fan controllers are designed to minimize electrical noise through the use of shielding, filtering, and optimized circuit layouts. However, even the best-designed controllers can still generate some level of electrical noise that can potentially trip AFCI breakers. The National Electrical Code, referred to as the NEC, recognizes the potential for electronic fan controllers to cause AFCI breakers to trip. The NEC provides guidelines for installing and using these devices in a way that minimizes the risk of nuisance tripping. These guidelines include using AFCI breakers that are specifically listed for use with ceiling fans, ensuring that all electrical connections are tight and secure, and avoiding running the fan at high speed. In some cases, it may be necessary to install a line filter to reduce the amount of electrical noise on the circuit. A line filter is a device that is designed to block high-frequency noise while allowing the normal 60 Hz alternating current power to pass through. Line filters can be installed at the fan controller, at the AFCI breaker, or at both locations. It is important to choose a line filter that is compatible with the voltage, current, and frequency of the electrical system. It is also important to follow the manufacturer's instructions for installation and use. When troubleshooting AFCI breaker tripping problems with electronic fan controllers, it is essential to have a systematic approach. Firstly, verify that the AFCI breaker is properly installed and wired. Secondly, check the fan controller and wiring for any signs of damage or loose connections. Thirdly, try replacing the AFCI breaker with a different model from a different manufacturer. Fourthly, try installing a line filter at the fan controller or the AFCI breaker. Fifthly, if the problem persists, consult with a licensed electrician. An electrician can use specialized test equipment to analyze the electrical circuit and identify the source of the problem. They can also recommend and install appropriate solutions to prevent nuisance tripping. It is important to note that AFCI breakers are designed to protect against dangerous arc faults, which can cause fires. It is never advisable to disable or bypass an AFCI breaker to prevent nuisance tripping. Doing so could compromise the safety of the electrical system and increase the risk of fire. If an AFCI breaker is tripping frequently, it is essential to identify and address the underlying cause of the problem. This may involve replacing the fan controller, installing a line filter, or upgrading the electrical wiring. By taking the necessary steps to resolve the problem, it is possible to ensure the safe and reliable operation of the electrical system. To further enhance understanding of this topic, it's beneficial to explore the specific technical characteristics of both AFCI breakers and electronic fan controllers in greater detail. Let's start with AFCI breakers. AFCI breakers utilize sophisticated electronic circuitry to differentiate between normal arcing events such as those occurring within the brushes of a motor and dangerous arc faults that indicate a potential fire hazard. This differentiation is achieved by analyzing the waveform of the current flowing through the circuit. Key characteristics that AFCI breakers monitor include the magnitude and frequency of current spikes, the presence of high-frequency noise, and the overall distortion of the current waveform. Different manufacturers employ varying algorithms and detection techniques to identify arc faults, which accounts for the differences in sensitivity and performance observed between different AFCI breaker models. Some AFCI breakers also incorporate features such as neutral wire monitoring to detect ground faults, which can also pose a fire risk. The tripping threshold of an AFCI breaker is the minimum level of arcing activity required to trigger the breaker to trip. This threshold is typically set to a level that is high enough to avoid nuisance tripping from normal arcing events, but low enough to detect dangerous arc faults quickly and reliably. The tripping time of an AFCI breaker is the amount of time it takes for the breaker to trip after an arc fault is detected. This time is typically very short, on the order of milliseconds, to minimize the risk of fire. Electronic fan controllers, as previously mentioned, employ triacs or other solid-state switching devices to regulate the speed of the fan motor. These devices rapidly switch the current on and off, creating a pulsating current waveform that contains high-frequency harmonics. The amplitude and frequency of these harmonics depend on the design of the controller, the switching frequency, and the characteristics of the fan motor. In addition to the switching harmonics, electronic fan controllers can also generate electromagnetic interference, referred to as EMI, which is radiated through the air and conducted through the electrical wiring. EMI can interfere with other electronic devices, including AFCI breakers, and can contribute to nuisance tripping. To mitigate EMI, high-quality fan controllers incorporate filtering and shielding techniques to suppress the generation and propagation of unwanted noise. These techniques include using ferrite beads, capacitors, and shielded enclosures to reduce the amplitude of high-frequency components in the current waveform. The design of the fan motor itself can also influence the amount of electrical noise generated by the controller. Motors with poor winding insulation or loose connections can generate arcing and sparking, which can exacerbate the problem of AFCI breaker tripping. When selecting an electronic fan controller for use with an AFCI protected circuit, it is advisable to choose a controller that is specifically designed to minimize electrical noise. These controllers typically incorporate advanced filtering and shielding techniques to reduce the risk of nuisance tripping. It is also important to ensure that the fan motor is in good condition and that all electrical connections are tight and secure. In summary, the interaction between AFCI breakers and electronic fan controllers is a complex issue that involves a variety of technical factors. By understanding the characteristics of both devices and by following best practices for installation and troubleshooting, it is possible to minimize the risk of nuisance tripping and ensure the safe and reliable operation of electrical systems.